Alright guys, so now we're going to incorporate everything we've learned about into something called the factor theorem. Okay, so what we're going to do, we're going to determine if the following are factors. So we're going to determine if our divisor is a factor, and if so, we will find the remaining factors. So let's just talk about what it means to be a factor. Okay, so when we're trying to figure out what it means to be a factor, let's break down a number and figure out what the factors are. So if I said, what are the factors of 12? Think about it for a minute. What are some factors of 12? Okay, some factors of 12 are things like 2 times 6, 3 times 4, 1 times 12. Okay, as factors are things that multiply to equal something. Factors are multiplying. Okay, so if we are dividing by a factor, because I want to know if this divisor is a factor. If we divide the factors into our original number, let's think about what the remainder would be. So like if you divide 2 into 12, it goes in 6 times and it goes in evenly. Okay, so it will not have a remainder. Same with the 6. If I divide 6 into 12, it goes in 2 times evenly, so it won't have a remainder. Same with the rest of these. Okay, so basically, if you do not end up with a remainder, or if your remainder is 0, then it will be a factor. Okay, so something to keep in mind. If our remainder is 0, then it is a factor. Okay, so if the remainder is 0, it will be a factor. Okay, because it will divide evenly into the polynomial, which means it has to be a factor of the number. Alright, so we're going to be doing some polynomial division, which with polynomial division, sorry guys, you can pick to either do long division or synthetic division. I don't care which technique you use. Now, me personally, I prefer to use synthetic division, but that's just a personal preference. So I'm going to set up my synthetic division. Okay, in my boxy, I'm going to put the opposite of my divisor, which is a positive one. I'm going to set up my synthetic line. Alright, so my highest exponent is x to the third. So we got x to the third, x squared, x to the first, and x to the 0. Alright, so the number in front of my x cubed is a 2. The number in front of my x squared is a 17. The number in front of my x is a 23. And the number without the x is negative 42. Alright, so if this is a factor, if this guy right here is a factor, then my remainder, my last number should be 0. So let's see what happens. Alright, I'm going to bring the 2 down. Then I'm going to multiply it to the 1. 2 times 1 gives me a 2. I'm going to slide it over. Add down. 17 plus 2 gives me a 19. I'm going to multiply it to the box. 19 times 1 gives me 19. I'm going to add down. 23 plus 19 will give me, let's see, 9, 12, 2, 3, 4. All right, and then 42 times 1, I multiply this to the 1. Okay, 42 times 1 is 42. I'm going to slide it over. And negative 42 plus 42 will give me a 0. Holy hot dog, you guys. This tells me right here that it's a factor. Yay. We love it when things are factors. Guys, so x minus 1 is a factor. So what we're going to do, we're trying to find the remaining factors, and in order to do that, we want to write our answer in factored form. So something like this. So since this is a factor, it is one of the factors in my answer. Okay, so far what we have in factored form, we know that x minus 1 is a factor. So I'm going to write that down. All right, and then this is whatever's left over after we divide x minus 1 into the polynomial. So as of right now, I don't care about this original dividend. I care about the resulting quotient down here, okay, which the resulting equation, you guys, is called the depressed equation. It's a little bit smaller than the start equation, and I guess it's kind of sad, so we call it depressed equation. I know it's depressing, right? Alright, so remember when we write our quotient or our answer, we start with one exponent less than our highest exponent. So we have an x to the third, 1 less than x to the third is x squared. So these are my coefficients, so we have 2x squared plus 19. Remember we go down by 1 each time, so we got x squared, x to the first or just x, and then the last one is the one without the x, so plus 42. Okay. So, we know that this is one of our factors, and we're getting this in factored form. So now what we have to do, you guys, we have to ask ourselves, can we keep factoring like we were just doing? Okay, this is the part that says find the remaining factors. So you have to keep asking yourself, could I keep factoring? And I hope so, because we love to factor. We love it. All right, so this one, okay, we have 3 terms. Okay, so looking at our chart. All right, guys, so we have 3 terms. Our options are slide and divide or the quadratic formula, but remember, if you use the quadratic formula, you got to move your number over into factored form. These are the zeros. These are factored form. Okay, I'm going to use slide and divide though, so let's see what happens when we do slide and divide. Okay, I'm going to do my slide and divide over here, kind of branch it off. All right, I'm going to slide and divide with this bad boy right here. So I'm sliding and dividing with this. Okay, so I got my 2x squared plus 19x plus 42. All right, my a is the number in front of x squared, which is 2. My b is the number in front of x, which is 19. And my c is the number on the end, which is 42. All right, guys, let's start sliding and dividing. So I'm going to slide my 2 over to be with the 42. So I'm sliding the a. Okay, so I'm sliding the 2, and remember, eventually we will be dividing by that. So I'm going to set up my final answer. Okay, which remember, our final answer always has x's in it, so eventually we're going to be dividing by this number. So I'm going to slide the 2 over, so eventually I'm going to divide by 2. Okay, so let's slide 2 over to 42 and we multiply. So I want to find 2 things that multiply to be 8 times c. So 2 times 42 will give me an 84. So I need 2 things that multiply to be 84 and add to be 19, which is b. So you always find 2 numbers that multiply to be AC and 1 number that adds to be B. So let's see here. 2 things that multiply to be 84 and add to be 19. Let's see. No, let's see. Give me a second, guys. This one's kind of tricky. Oh. All right, so let's see here for a second. Let me think. So 3 doesn't work. 2 doesn't work. Does 4 work? Let's see. 4, 2, 1. No, 4 won't work. Let's see. 6 goes into 1. 6 and... No, that won't work. Let's see. Will 12 work? 12 times... Let's see. I think 12 might work, you guys. Let's see. 12 times 7, I think. Yes, okay. Sorry, sometimes you gotta think about it for a second, you guys. So, 12 and 7 will multiply to be 84 and add to be 19. So let's see. Okay, so we got our 12 and our 7. All right, so these are our 2 numbers that multiply to be 84 and add to be 19. Okay, so these are the numbers I'm going to put in my parentheses. I have a positive 12, so it'll be plus 12, and I have a positive 7, so it'll be plus 7. All right, guys, remember the last step is to reduce these down. So 12 divided by 2 will reduce down into x plus 6. 7 divided by 2 will not reduce down. But remember, we do not like to see this fraction right here. So remember, the way we get rid of the fraction, we can move this number in front of the x and we will get the same thing. So this will be 2 times x. And when we remove the 2, we're left with just plus 7. So yay, this would be this guy in factored form. All right, so we have factored this. Now, when we write this in factored form, so we're going to write all the factors. So I'm going to bring down the original factor we found, which was x minus 1. And then I'm going to bring over these 2, which is when we broke this guy down into its remaining factors. So we have x plus 6 times 2x plus 7. All right, guys, so we determined that this was a factor, holy hot dog, and then we found the remaining factors. And that's it, you guys. Awesome job.